IRA's installation with regulation varies globally, but generally aligning with international electrotechnical commission IEC recommendations. The equipment we use is first is earth electrode. Earth electrode is a device used to connect electrical system to the ground. It's essentially a conductor, often made of metal like copper or steel. Secondly, we use the ground resistance. Ground resistance measure how easily electrical current can flow from an electrical system into the earth. Third is we use a digital multimeter. It's a handheld electronic device used to measure various electrical properties.
Okay, for the method for measuring the system, standard technique in electrical restoration testing, method is used, and then the auxiliary code and pulse. So inject pulse and then through auxiliary electrode, and then the earth electrode will be test. That is the method for measuring. So this is for triple measurement method. Triple measurement method is involved using electrode inject current electrode to inject pulse, right? To inject pulse and provide zero potential, and then positioning the electrode relative to earth electrode is crucial to avoid any interference. Okay, so the zero potential must be placed at the outside from the plan. Yeah. Then earth electrode due to current flow. Okay, then the setup to ensure accurate earth resistance measurement with auxiliary electrode position tested across different distance and device stable potential zone.
Okay. Ada. Okay, so for the procedure of this experiment, that we do step by step. Okay, so for the first one, we need to connect the two different electrodes. The first one we set it is as a reference electrode that we need to make sure there are no voltage decrease at the electrode, which is as fundamental we need to get 0 volt. Okay, so this EX and HZ is the probe that we connect from the meter. Okay, so for the next step, we determine the distance between the 2 points of electrode. Okay, and we start multiple it by x time over the period. Okay, so the next one, we connect the earthing system and stack the HZ that we connect to the probe at the meter to the resistance measurement measuring instrument, which is measure that we use. Potential stack, the is T. We step into the soil. Okay, which is the distance is 10% between the distance of EX and HZ. Okay, so we repeat 20%, 30%, 50, 60, and 70 between the distance. And the next step, if we have done the procedure, we identify the second edit system, which is the system which is the closed system first, and then we repeat this step, which is step 5, which is 10% until 70% with different kind of measurement, parallel with another probe and parallel another one. Okay, so the data that we get here.
The resistor values self-rotation but frequently within a relative narrow between 211 and 326 ohms, which is between 6 meters until 9 meters. Then, however, this significant drop resistance at 40% distance, which is 6 meters, the outlier, and the result we get from in the 40% is 211 ohms. Then next, the result is maybe is soil condition and the connective objects or measurement errors. Then for more investigation, pinpoint of this anomaly and assess its about the for the parallel result lighting system, we also use the same distance, which is 0.5 until 9 meters. So we can see as the distance increase, the resistance also increase. So the table before shows that this result shows that parallel lighting system is functional as expected, with increasing resistance as the distance from the earthing point grows. So the relatively small increment in resistance between the measurements suggests a well-distributed and effective grounding system. So this is likely due to the parallel arrangement, which distribute the current flow across multiple grounding points, reducing overall resistance. So for conclusion, we can see that from the single urging system test, it shows a drop at the 40% percentage, which is 6 meters. But for the parallel, it shows stable values for the resistance. So overall, the parallel urging system appears to offer more stable.
Just for, I want to sketch. You open stars. Okay. Can I sketch? Okay. Can you show me how the system is significant to measure R? The concept of three-wire measurement is significant or reliable for measuring R. In this case is berapa surrounding measurement, right?
Yeah.
So can you show me?
V equal to IR. V equal to IR for parallel.
Syariah.
I mean, no, you show the schematic first. The schematic, right? I mean, this one, the schematic. Then show me how it is clear. It's really clear that significant measure.
Schematic.
But for the
Oh,
case
based
of
on the
multimeter-
schematic.
Yeah, based on the schematic.
Lukis yang parallel tu dekat notes tu.
Like, for example, multimeter, you can't you can only measure for a certain passive measurement. I mean, from one point to another point. So that's what you can determine. But this one, you can measure proper significant or reliable. So then how?
Bukan schematic. Ni.
Yeah, show me.
Case what?
You already have the figure. You already have.
Think it's
First, the system allow you to create
Potential.
potential. The
Wave.
wave proper.
Propagate.
Propagation.
Secondly, you have potential between these 2 points, where basically these 2 points is the 50 volt.
Oh.
And then this is the current. So this where you are depends on the distance between Earth and stack.
Lagi dekat, lagi tinggi potential.
It depends on the soil property. So you have current. This is basically fixed, and this is also fixed.
50.
Only these things
Change.
show variation depends on the property of distance as well as soil. Understand? So that one is lacking in your slide. You don't have that kind of explanation. So please improve. Now my second question. So imagine you are working under constraint. In your case, you have achieved 72.5. So imagine in this additional area, say you have this is basically from earthing, original earthing, then you have 2 spike, right? Sorry, first, second, third, right? You have third, right?
Third.
Third. So then you achieve 72. So imagine this is only limitation space that you have, and you are expected that this space will perform from 80 to 90 ohm. Okay? So then can you estimate how many copper peak require to have in such a way that it can reduce the resistance to less than 10 ohm. Now you already have three rod. Right?
3 rod for
Right, then you
72.5.
get 72.5. And then now you want to improve. You want to improve in such a way that it can reduce
Lower
less
than 10.
10 ohm.
Yes.
Okay, now you expected that this area with having resistance within the range of 80 to 90. So can you expect how many copper rod require to have in such a way that it can reduce to less than 10 ohm? Okay, right? O and think carefully. You have 5 mind, so think carefully how to solve it. Eh? Can show clearly in terms of schematic. draw clearly, show how you can reduce. Of course, this is something related to calculation. Okay? When, for instance, if you imagine that this is 80, right? So it means that 1 over 2.5 plus 1
1 over 70,
80, right?
1 over 90.
So can you calculate?
Can.
Sure. Calculate.
Phone lah.
Come on, man.
Mana phone?
I already teach you, right? Install this video.
Ha. 1 oh.
Why? You install. So, 1
Oh, 72.5
72
plus
plus
1 over 80. 80. Good.
So now by adding 4,
Yeah.
then it can reduce to 38, right?
Yeah.
So think, how many?
Another 2.
Of course you have to calculate lah. Then you will see. Okay, thank you very much. Any question? Any question? Dah okay lah? Boleh?
Ha.
Siapa? Mama mengantuk ke? Masuk pemandu tu?
Bukan, tanya